Welcome to the course on Python Basics for Data Science. In this session, we're going to learn everything you need to learn about Python as a language to get started with Python programming. I am Sanket Sarang, founder and chief of products at BlobCity. BlobCity is a pure-play data analytics company with a product of its own and also offering its BlobCity AI Cloud, which is a premium cloud service for running data science models on the cloud environment. We provide you access with Jupyter notebooks, and we will be doing today's course using the BlobCity Cloud. Personally, I started programming at the age of 10. I went on to building my first social media chat app at the age of 20. Then I built a full-feature NoSQL database at the age of 26. This database can still be found on GitHub, so you can just Google BlobCity DB GitHub and you will find my database. I've personally spoken at a lot of events. You might find some of these videos on YouTube. I've trained senior executives. I've taken a lot of trainings, including data science trainings, language trainings for several senior executives for several large multinational corporations. I'm myself a mentor to several startups, and I also happen to be an angel investor. Today's course is all about covering the basics of the Python language. This is the language that you must know to become a data scientist. So if you're planning on having a data science journey, you're planning on becoming a data scientist, or simply learning data science so that you can manage data science teams, then you're at the right place. This course is the first course that you must take in beginning your journey in the field of data science. Before we start with Python, let us first take 2 minutes to understand what is data science. So data science is simply explained as an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data, right? So data science comes at the intersection of domain expertise, computer science, and mathematics, which means simple programming will not make you a data scientist. You need to have computer science knowledge for sure, which might be basic programming knowledge, the ability to use a computer, and the ability to do data science on a computer, right? So Python language is our means to teach you how to do data science with a computer. And this is what we will be covering in today's course. However, to become a data scientist, there are additional skill sets that you will have to build. These skill sets include the skill sets of domain expertise, which means you need to have a good understanding of the domain in which you're operating. So if you're trying to do data science for, say, the mining industry, you need to have domain knowledge of mining. If you're doing data science for logistics, you need to have domain knowledge of logistics. You could be doing it for aerospace, you could be doing it for manufacturing, for retail, for e-commerce, doesn't matter. Whatever you're doing data science for, without the necessary domain knowledge, you won't be an effective data scientist. So simple Python programming, along with the ability to understand and write Python data science models, does not make you a data scientist. Domain knowledge is equally important to become a data scientist. Now, in addition to the computer programming skills, domain expertise, you need mathematics. The mathematics required for data science is typically the basic college level mathematics. So if you've studied math in college, you should be good enough with the mathematics. However, in certain cases, you might need to take refresher course, like equation of a line, straight line, you might remember, which is y equals to mx plus c, but you might not remember the equation of polynomial lines, or you might not remember what a 95th percentile actually means. So those things you might have to take refresher knowledge. And during our training, whenever there's some amount of mathematics, I will try to kind of impart some of that refresher knowledge. But you need to have basic understanding of mathematics to understand this, right? Proceeding further with this training, I kind of assume that you have programmed before. So if you've never programmed before, you might find it really hard to follow through on this because this is a live coding session, and I want you to follow through with me in coding. You don't need anything other than a browser and a computer to code with me. That's all you need. We'll be giving you all the cloud infrastructure that you need to conduct the training, right? To conduct the coding and code along with me. But you need to have some prior programming experience. You don't need to have any experience with Python, right? It's my job to teach you Python. But I won't be covering the basics of programming. So I won't be covering what is an array, or what is a variable, or what is a function, what is a class. I won't be covering this. I expect that you have some basic knowledge of programming before you proceed further in this module. Before we get to coding with Python, let's understand some of the basics of the language. Question number 1, who created Python? Right, so the Python was created by Guido van Rossum, and it was released in 1991 as a programming language. He was the sole author of the language, so he created the language on his own at his own time. There are 5 quick facts about Python. Let's look at 5 really interesting facts about Python. Fact number 1, Python was actually a hobby project of Rossum, right? So in December 1989, Python's creator was basically looking for a hobby project to keep himself occupied in the week around Christmas. So Christmas time, you have the holidays. If you're not on vacation, you're sitting at home, it's too cold to do outdoor activities. That is exactly what Rossum was. That's the situation that Rossum was in. And he wanted a hobby project to work on. So being a programmer, he was thinking of, writing a new scripting language that would be a descendant of the ABC language and also appeal to Unix and C hackers. So he started building this language, and he chose to call it Python. Now, fact number 2, Python is actually a very unique name, right? So is the name of Python actually coming from snakes? Is it referred to the Python snake? The actual answer to this is no. So the language's name isn't really about snakes, but about the popular British comedy troupe, which was called Monty Python, right? And this was played in the 1970s. And Rossum was in a completely irrelevant mood. So when he created this scripting language, he just decided to call it Python because he really didn't think it mattered what you called it. So he liked the comedy, so he just called it Python. And that's how the name of Python came into being. Now, going further, Tim Peters has actually been a major contributor into the Python project, right? And Tim Peters, while moving on forward, he defined a poem, so they built something interesting. So even today, if you open the Python console or you open your terminal and you get into the Python shell, you can actually type this command called import this. And the moment you type import this, it prints out a poem. The name of the poem is called the Zen of Python by Tim Peters. And this actually explains the ideology of Python as a programming language, right? So the poem reads, I'm going to read this out, most of it. So the poem reads, beautiful is better than ugly, right? And keep in mind that he is referring to how Python is designed as a language and how you would code in Python, right? So beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. And complex is better than complicated, right? So simple is better than complex, and complex is better than complicated. Now flat is better than nested. Sparse is better than dense. Readability counts, right? Again, readability counts. Special cases aren't special enough to break the rules. Okay, special cases aren't special enough to break the rules, although practicality beats purity. So, practicality beats purity. Errors should never pass silently unless explicitly silenced. Errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. although that way may not be obvious at first unless you are Dutch, now is better than never. Although never is often better than right now. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea, period. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea, which means it is not necessarily a good idea. Let me repeat. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of this, and so on. This is the heart of the Python language. This is the poem written by Tim Peters, and you can even today go into the Python shell and fire the command import this, and you will see this poem pop up. Now, Python has become very, very popular in the recent times. So it is used by several large companies. Companies like Walt Disney, Netflix, NASA, Spotify, Shutterstock, Uber, IBM, Quora, they all use Python as a language. They have some form, they're using it in some form or the other. They have some code or the other that's actually running on Python as of now, as you're watching this video. Right? Now, Python is actually said that it makes you fly, right? So there was this joke that came up which said that Python can make you fly. And there's this comedy that is available. So if you type import anti-gravity, instead of import this, you can type import anti-gravity, and Python will open this web browser for you. It'll open a web browser for you, and it'll read out the comic which says, like, you're flying, how? And the person responds, Python. I'm flying because I am Python, or I write Python. Now, interestingly, while we know that the name Python didn't actually come from the snakes, the logo of Python has two snakes, right? So this is actually based on the Mayan representations of snakes, which very often represent only the head and perhaps a very short length of the tail, right? So the structure of the snake represents the natural coiling / nesting of a snake as seen from the side. Right, so the logo of Python is inspired by snakes. It is inspired by the Python being a snake, but the name Python didn't actually come from the snakes. Now, why would you use Python as a language, right? There are a few reasons why you would use Python as a language, and it's a preferred language in several cases. So first thing is Python works on different platforms, which means whether you're doing Windows, Mac, Linux, Raspberry Pi, or any other, Python is most likely supported on all those languages. Python also happens to have extremely simple syntax, and it is very similar to English language, which is why most people look at it as a pseudo-coding environment, wherein code written in Python typically appears as if it's like you've written an algorithm. Now, Python has syntax that allows developers to write programs with fewer lines of code than other programming languages. So while you go through this course, you will actually notice that in several other languages, the amount of boilerplate code, as we call it, is substantially large. Python comparatively has much lesser boilerplate code, which means in fewer lines of code, you can achieve much more. And in other languages, you would have to write several more lines of code to achieve the same thing that you can do with fewer lines of code in Python. Now, also Python does not have a compiler. So Python runs on an interpreter system. So this means that the code can be executed as soon as it is written, right? Which makes it easy for fast prototyping. And you're going to notice this throughout this session, wherein we will be writing bits and pieces of code and we'll be executing it over and over again. And you will notice that we don't have to compile it. We don't have to start from a main method. We don't have to start from scratch. It's just a few lines of code and we can start from wherever we want and run it how many ever times we want, right? And that's only because Python runs on an interpreter system. It doesn't work on a build and a compile system. Now, Python gives you flexibility of programming. So you can write Python code in procedural way. You could also write it in object-oriented way if you so desire. Python supports your classes, your objects, all of that to write object-oriented code. But it also supports advanced methods like functions as objects, then lambda functions, which are predominantly used in functional programming languages. So Python gives you the ability to also write functional code if you so desire. So Python is one of the few languages that offers complete flexibility, which means you can write procedural code, you can write object-oriented code, you can also write functional code. So the choice is yours. Many people I know choose to use Python predominantly in a functional way and definitely not in the object-oriented way. So most of the Python programs I'm used to are written in the functional way. And for data science, I would prefer that you write in the functional way. So if you don't know functional programming, we will cover some bits and pieces of it as we go along in the session. So are we ready to get started? Are we ready to start writing a first program in Python? And the first program inevitably being the Hello World program in Python. Are you ready? If so, let's get started. Before we get started, there's one important thing that we need to do. I want you to follow the setup instructions to set up your Cloudbook. Cloudbook is BlobCity's data science notebook on the cloud. It's offered as part of a premium offering, which is the BlobCity AI Cloud. Cloudbooks give you Jupyter notebooks on the cloud, and these Jupyter notebooks is something that we're going to use for our coding. So in 5 simple steps, I strongly encourage that you set up your Cloudbooks and get them spinning. All you have to do is follow the link in the description of this video. Once the page opens, hit the Copy Cloudbook button. If you're already registered, you can directly log in, copy the Cloudbook, open your first notebook, and you're good to go. If you're not registered, then you can quickly register, enter your name and email address to complete the registration. As soon as you enter your email address and the name, you will receive an email from us with password setup instructions. Follow the instructions on the email to set up your password. Once your password is set up, you can log in, and then you can hit the Copy Cloudbook button to copy your Cloudbook. Once your Cloudbook is running, you would see this code, which is the code that we'll be following. So this is a code along session, and I strongly encourage that you follow me in the code along session. To make the most of this session, coding along with me is important. If you're a new member of BlobCity, you might be presented with the pricing screen. So you can see a free plan, you can see paid plans. Choose the free plan. You don't have to take a paid plan. The free plan covers you for one Cloudbook, and it's free for life. It's not a trial. It is a complete free for life account, and you can create up to one private Cloudbook inside the free plan. Later on, if you need more Cloudbooks, you can always upgrade to one of the premium plans. So we're going to give about another 2.5 minutes for everyone to spin up their Cloudbooks. And if you've not started doing it now, I strongly encourage you to start doing it. It should not take you more than 5 minutes to spin up your first Cloudbook. Copy my Cloudbook because I'll be using this Cloudbook throughout the training. As soon as you open the Cloudbook, you can go to the lesson 1. You can hit the run button on lesson 1. Lesson 1 starts with the Hello World program. Just like any other programming language, we will be starting with the Hello World program in BlobCity. Keep in mind, to follow the session, you don't need to have anything installed on your computer. Just your BlobCity AI Cloud account, a free account should do, a browser, and you're good to go. If you're watching this training from an iPad, you can simply open the Cloudbook through the iPad. You can literally code from the iPad. All the computational resources are covered on the server. All our plans come with unlimited compute, unlimited storage, and unlimited RAM, which means whether you're running a small project in data science or you're running a very, very large project in data science, we have you covered with all the cloud resources. And the free plan gives you unlimited compute, unlimited storage, and unlimited RAM. It also gives you up to 30 days of runtime on your Cloudbook, which is the largest in the industry for any free Jupyter Notebook account. We also support GPUs from our $75 plan and above. So if you're looking for state-of-the-art GPU support to accelerate some of your data science models, typically image processing, deep learning, if you need GPU access, you can always take some of our premium plans to get GPU support. So by now, I hope you have your Cloudbooks running. It definitely cannot take more than 5 minutes to spin up your Cloudbook. Keep in mind, a common problem is a pop-up blocker. So when you hit the Open Cloudbook button, if you have a pop-up blocker on your browser, it'll block the pop-up. So do allow the pop-up from our website. You can just go and mark it to allow. You can just click on the blocker and it should allow the pop-up, and your Cloudbook should be up and running. Once your Cloudbook is running, go inside lesson 1, and that's where we'll be starting. It's the last 15 seconds. If you don't have your Cloudbooks running yet, I strongly encourage that you do so. Get them running anytime now. Okay, so by now, all of you should be on this screen. So you should have lesson 1, Hello World, opened up. Now, why do we take Hello World as the program to start with, right? That's a question you can ask. So the simplest answer to this question is most programming languages start with an Hello World program. So even in the case of Python, let us start with an Hello World program. So how would you write an Hello World program, right? The simplest way to write an Hello World program is all you do is you say print Hello World and you have a Hello World program. Now, you might be familiar that in many languages, you have to write a lot of code, right? Which is you create a class file, you create a main method, you might have heard of public static void main, right? And then inside the main function, you create a print statement that actually says hello world, right? Now, will this statement actually work in Python language? The answer to the question is yes, it will work in Python language. So is this a valid hello world program? Yes, it is a valid hello world program. So how do you run this, right? So to run this program, I'm simply going to hit the run button over here inside the Jupyter Notebook console. So when I hit run, you can see it shows the output here itself. So this is very different. Jupyter Notebooks are very, very different than some of the traditional programming IDEs that you're comfortable with, right? So in a traditional sense, you would basically expect to write all the code in one place, and then you would expect to build the program, and then when you run the program, you see some other interface or an output window or a terminal screen which shows you the output of the program. However, in the case of Jupyter Notebooks, that's not the case, or typically with Python or especially the IPython shell, that is not the case. So Jupyter Notebooks allows you to split your programs into logical code blocks. So what you see here is another logical code block. So all these numbers that you see here, the line numbers, so this is 1, and this will be 2, then 3, then 4, then 5, right? All of those are essentially different logical code blocks. And I can create as many code blocks as I like. And I can also add as many lines as I want in a single code block. So this is the Hello World code block. It's important to note that in Python, I did not have to write anything else, right? I just wrote print hello world and we have our hello world program up and running. Now, if you have Python properly installed on the computer, if you're running this on your computer, this line of code will directly work for you, right? At this point in time, I expect that all of you are with me and are actually able to run this program. So you have this file open and you're able to hit the run button. If you're not with me here and you're not able to hit the run button, and if you hit the run button and you don't see the hello world output, I highly recommend you pause this video and hold it till the time you reach this point, because now things are going to get really interesting. And I want you to follow along with me in the coding, because that's the best way to learn, right? Once we have executed this, let's hit the run button again. You can see it printed hello. Now I'm going to go further down, right? So in further down, I'm going to define my first variable. So I say my number equals 10. So this line of code that you see is my first variable. However, all these lines of codes that you see are actually comments. They're not executable lines of code. So you might see them even from the color highlight. They're a little grayed out, which kind of indicate that those are non-executable lines of code. It is actually comments that you're writing. Now, in many programming languages, you might be used to comments with a double slash, right? Double slash or slash star for multi-line comments. That's not how it works in Python. So in Python, anything you write after a hash actually becomes a comment. Now, at this point in time on this line, we have actually said my number equals 10. So we created a first variable and we called the variable my number. So my number is the name of the variable and 10 is the value associated with this variable. Moving on, we want to print the value of the variable. Just the way we printed hello world, let's see if we can print the value of the variable. So if I run this through, you can see that it printed my number and it says the value of my number is 10, which is actually correct because I set the value of the variable to 10, right? Now, moving on further, I can actually also use a shortcut to print the value of my variable, right? So in this case, I'm actually defining the variable and equating it to 10. But in this case, if I just put the number itself, if I just put the variable itself, okay, this statement is equivalent to the print statement. So they're both almost the same thing. So let's see what happens when I do this. If I run this, my output is also 10, right? So even in this case, I can actually view the value of the variable on the line. Now this is basically raw display of content, while print will do some level of formatting. So if you try this with a string, you might get slightly differential output. Like if you have new lines, you might actually see a /n instead of seeing a new line. So all that might actually happen. But it kind of does the same thing. If all you wanted to do was view the value of the variable, you could just put my number and you can view the value of the variable, right? Now, in addition, Python allows you to quickly view general information related to variables, right? And the way you do this is by adding a question mark after the variable, right? It also works with adding a question mark before the variable. Both actually work. So let's execute this line of code and we want to see what is the general information that Python has around this variable, which is called my number. So if I execute this line, you can see that this pop-up now appeared in my Jupyter Notebook's interface. This pop-up tells me important values, right? So the value of the variable is type int. I can see that the value is actually set to 10, and it gives me a docstring interface. This is a documentation on what an integer is, how to convert a number to a string and vice versa, and all of that. So it gives me relevant information of the variable. The most relevant information you're most likely to look at is this value, is this value, which is the type of the variable, because you might want to look at it at multiple times. So if you just want to debug and you want to see what is the type of the variable, you can look at the type. Right? It's important to note that we actually did not assign a type to the variable. So at this point in time, I did not say it is int number equals 10. I just said my number equals 10, right? I did not explicitly specify what is the type of the variable, right? And it's interesting to note how Python starts interpreting the types of the variables. So we're going to look at that, a little down further in this training. Now, just as I said, this statement, when I run this, it shows me information related to the variable. I can also write the statement in the reverse manner, which is this line of code, which is question mark my number, also actually does the same thing. So if I run question mark my number, I get back the same exact thing. There's no difference between the two, right? Now, let's say instead of an integer, I wanted to define a string, right? So how would I define a string? So I can do that by saying my string equals hello world, and I'm creating a new variable at this point in time, and the name of this variable is called my string. So if I execute this line, my variable is essentially created. I don't expect any output here, so it's simply going to run it through, right? The moment you see a number here, which is like 12 that you see here, it actually means that the cell is executed. In some cases, it might take a while for your cell to execute, in which case it's actually going to show you a star over there. So while it's executing, it'll show you a star. And when the star is gone, that's when you know that the cell has actually executed, right? Now, let's say I want to print the value of my string, right? So I can just do print my string, or I can just do my string. Both actually work. So I'm just run this through, and you can see it shows me hello world, and this shows me hello world, right? Now you can notice that there is a slight difference, right? Because my string prints the absolute raw value set on this object. So it's actually printing the object itself. But you can see that when I use the print function actually does certain amount of formatting. So it does not show me the original quotes, etc. that I set on the object. It just gives me a formatted output. So in most cases, if you really want to properly view the value of a variable, I highly recommend using the print statement instead of just outputting it as a variable. However, if you do encounter code that just says my string and that's the only thing that you see on the line, and that's the only variable, it could be variable, could be at any type, it doesn't matter. If you just see that line there, then you know what that does, because I've actually noticed that a lot of people who come from object-oriented programming languages often get confused when they see this type of code. They really don't know what is going on there because they're not kind of used to a line of code that simply says my string. They're also not used to something like my string equals hello world, because then the question is, where did I actually define my string? Right? Did I actually say somewhere like string my string equals null? Did I say that somewhere? Right? Which is a common practice in many languages, is you first have to define the variable, then you can assign a value to the variable. However, Python gives you full flexibility, which means when you first use this variable my string and give it a value hello world, it does dual functions. It actually defines the variable for you. But if the variable is already defined, it will change the value of that variable. And changing the value of a variable in Python is equivalent to creating a new variable. There's almost no difference between the two, right? So many get confused on where's the variable actually defined. It's not defined anywhere else. This is the line. This is where it's defined. This is all it takes in Python. This is also why Python actually has very little boilerplate code. So when we say boilerplate, it basically means extra code that you have to write to run your primary code. And Python allows us to have very little boilerplate code. So moving on, we can see that when we print these values, both print myString and myString, both of them actually work equally well. Now let's look at the type of myString, right? So I can go on this cell, I can hit the run button. When I hit the run button, you can see it shows me the form of the string is hello world, the length of the string is as 11, right? And it shows me the type of the variable as str, which is a string type. In the previous case, the type of the variable was an int. In this case, the type of a variable is a string, right? Now it is interesting to note that in none of the places we actually explicitly set the type of the variable, right? So what Python did as a language is it actually computed the type of the variable on its own, right? It actually did it on its own. Now, one interesting thing that we saw is we actually use a hash to define a comment, right? And many of you might know that you typically use a /* to use multi-line comments, right? So in many languages, something like /* and then anything you type here, and then */ is how you would define a multi-line comment, right? And a single line comment would be something like this, where this is a comment. This clearly, obviously doesn't work in Python, right? You have to use the hash. But how do you do a multi-line comment in Python, right? So an example of this is you can actually put it in triple quotes, right? So you can put it in triple quotes. So you put triple quotes, and then you write anything you want inside there, and this kind of acts like a multi-line comment, right? However, it is important to note that what we have created here is not a multi-line comment. We have actually created a string literal. So you can define a string by saying, you can define a string like hello world, and this is legal syntax. But I cannot define a string that says hello world. You see, this breaks because this actually put it in black color over here, which means something went off. So if I want a multi-line string, the only way to do a multi-line string is actually to start it with triple quotes. And when I start it with triple quotes and then I end it with triple quotes, this becomes a multi-line string. So you put triple quotes to start and additional triple quotes to end. And when you do this, it becomes a multi-line string in Python, right? Now, people sometimes use multi-line strings, which are essentially string literals, to write multi-line comments. So that is one way in which you could do it. However, if you're using Jupyter notebooks, you would most likely not write comments in your code, right? Because you can actually include documentation along with your code. So you can have various types for your cells. So you can see this particular cell is actually of type code, right? So I can have different types. I can have it of type heading, raw, NB convert, or I can have it markdown. So typically you would use a combination of code and markdown. So if you choose a markdown, then it allows you markdown language based documentation on your code. And that markdown documentation is what is most commonly used along with Jupyter notebooks, right? So let's run this through, right? And when I run this through, you can actually see that, there's stuff getting printed here, right? And you can see that while I used a multi-line text, I don't actually see that in multi-line. So this is actually a string literal. And when you use a string literal by itself, just the way like you use a variable by itself, it will print the value of that variable. Just like that, it's printing the value of the string literal, right? Now, this is what I'm doing here when I'm actually using multi-line comments, right? So, but you can notice that this is unformatted text. So it started with the single quote, it started with a /n. The /n represents the new line, right? And everywhere there's a new line, there is a /n. So you can see my string is str, and over here we begin a new line. So however goes on a new line. So you can see here that just before however, you see a /n. /n in programming terms basically means a new line. For all those who are completely new to programming, do not know what /n means, /n represents a new line, right? Now let's move a little further down, right? Now there are various ways in which you can define a string and both are valid. So I can say my string equals hello world in single quotes, right? Or I can say my string equal to hello world in double quotes, right? So notice the difference here. It's single quotes and double quotes. Both are actually legal syntaxes. So what happens is in certain languages only double quotes are accepted, in certain languages only single quotes are accepted. So this kind of creates confusion amongst developers, right? So Python basically gives you that flexibility where it says that you choose whichever form you like and you use it. It doesn't really matter. You can choose single quotes or double quotes. They actually kind of mean the same thing. It won't have any impact at all in whatsoever you're doing. Similarly, you can have multi-line comments in single quotes. You can also have multi-line comments in double quotes, 3 double quotes or 3 single quotes. They also mean the same thing, right? So let's go further from here, right? And let's see how to set a variable to a multi-line string, right? For example, so I can actually say my string equals, and in the beginning, I have these 3 quotations to start with, and then I can write a multi-line string, and then I close it. This becomes a multi-line string, right? At this point in time, I'm going to just go ahead and print it to see what prints. So in the previous case, you notice that it printed with the /n, right? So when I used a multi-line string, and I just printed the value of the multi-line, it just used it, right? Which is equivalent to just putting the variable there for print. You can see it came with the /n. Now over here, I'm going to assign it to a variable, right? And I'm going to run this. And when I assign it to a variable and run it, and I use a print function, right? This print function essentially gives me formatted output. So when I look at the output of the print function, I lined up with this is a multi-line hello world program, right? This actually shows me that this is a multi-line hello world program. And I don't see the /n's here. I see well-formatted string, right? However, on the other hand, if I was to do this a little differently, right, I can just do my string to print it, right? I don't really have to do print my string. So you see what happens here? It doesn't show me the multi-line anymore, because when I enter a new line to a program, it means a /n. It's not actually a new line. It's the formatting tool that prints the new line every time it encounters a /n character. So over here, you can actually see this prints my object in raw form. It doesn't actually print it in a pretty form. But in most cases, you would want your objects in a pretty form. So you would just go with something like print my string. And this would be the right way to do. And this is what I recommend you should do in most cases. Okay. So here we come to our first exercise, right? And I'm going to recommend you actually practice this exercise. So you take this notebook and you write code here to actually practice an exercise and play around with it, right? And I want you to give this a try. Not right now. Give it a try later. Whenever you have time, spend some time doing this. So after each and every module that we cover, I will be giving certain exercises for you to practice. And I highly recommend you practice these because you will really become very proficient in Python as a programming language if you're able to do all of the exercises. I've now opened Lesson 2, Language Semantics. let's take a look at some of the language semantics of the Python language, right? Python is a little different from some of the most commonly used programming languages. So I'm going to take an example of a for loop inside Java, right? I assume all of you know for loops, right? And I assume all of you come from a programming background to a certain extent. However, we will be covering loops a little more in detail, but here just play along with me because I want to explain something different than loops. Now, if I was to take a loop in Java language, I would basically write something like this, wherein I could have my array, which is an array, and inside the array, I'm going to just run this through. So inside the array, I have a value, int val. So I'm assigning value and I'm iterating through every element in the array. And then for each iteration, I'm doing a system.out.println, which is essentially going to print the value of the array, right? Now, let's say I try to do the same thing in Python, right? So over here, I define my array. It is called my array equals, I simply put it like 1, 2, 3, right? This is similar to defining variables. You don't have to define it as a type of an array or anything of that sort. You simply create the variable and assign an array of values to it, and then it becomes an array, right? And we'll cover this a little more further down in the course. Now, if I want to iterate through this array, I can write this as for x in my array, and then there's a colon there. If you look at that, right, there's a colon there. And then after that, inside that, I have print x, and there is an indentation that I've actually used to do the print x, right? Now, this code does exactly same as what the Java code would do. So I'm going to run this through, and if I run this through, you can see it prints value 1, 2, 3. Right? And this is actually 3 values in the array. It iterates through all the elements in the array and it prints the array, right? Now, what's important to note here is the colon that you see here does the job of the curly brace open, right? So in Java, when you open a curly brace, you're saying that I'm starting a new section of block, right? In Python, to start a new section of block, you simply use a colon. And every time you put a colon, you're starting a new section of a code block. Now, how do you know what comes inside that code block and what comes outside that code block, right? So anything you put inside the next line follows after a colon, which is indented. So anything that you put inside an indentation is what goes inside the primary main block, right? So if you move further down through this, right, and we look at this piece of code, so I have written 2 lines here, right? The question is, will these 2 lines execute inside the for loop, or will my bottom line execute outside the for loop, right? So print b, and I'm just doing a string concatenations. I'm just basically converting the value of x, which is of integer type, to a value of string, and then I can concatenate 2 strings. Right? So will this print b also get included inside the for loop, or will it be outside the for loop? Right? That's the question. Now, let's just run through this and see. Right? Now, you can see that in the for loop, a printed value of 1, then b printed the same value 1, which is the same value of x, right? Then a printed 2, b printed 2, a printed 3, and then b printed 3, right? So we can see that both the print statements are actually inside the for loop. And the reason these print statements are inside the for loop is because you have this indentation, right? And this indentation is what defines them to be within the for loop, right? Now, I'm going to pick a topic that I probably don't want to pick up here, right? So this you can do this indentation in multiple ways. So you could put tabs, or you can put 4 spaces, right? This is the common universally accepted standards is you choose between a tab or 4 spaces, right? Some people use 2 spaces, which is also fine, but you universally choose between a tab and 4 spaces. I personally prefer 4 spaces. There are IDEs that prefer 4 spaces, but there are some developers who prefer tabs. Some IDEs actually support converting tabs to 4 spaces automatically. The reason you would use 4 spaces is because in some visual viewers, the viewer would basically misalign a tab, right? So it would replace a tab with a single space, or simply misalign the tab. And if you misalign the tab, the code in Python is going to have a different meaning if your indentation is missed. So it's a good practice to actually use 4 spaces. I personally prefer 4 spaces, but I do prefer typing a tab and then I want the IDE to convert it into 4 spaces. So when I go through my cursor, you can see this is 1, 2, 3, 4, right? So those are 4 spaces that you can see there, 1, 2, 3, 4, right? So it's actually 4 spaces that are there. Now, all these lines that come in the indentation, I can put as many as I want. So if I just hit enter, you can notice that it just puts it in the same line, right? It actually comes with the indentation. I don't have to do anything, right? Everything that you put here is actually within the for loop. It's not outside the for loop, right? So where does the for loop actually end, right? So let's move on to the next cell. Let's look at this example. The question is whether this print hello would be inside the for loop or outside the for loop, right? In this case, this print hello statement is going to be outside the for loop. So to break the braces of the for loop, if I may say, right? So you could actually put braces in other languages, right? But to break the braces of the for loop, you basically do a reverse indentation. So the moment you do a reverse indentation or you remove the indentation, this statement comes outside the for loop, right? So if I run this, you will notice that these lines of code all got executed inside the for loop because they ran 3 times each, 1 for each value in the array, but hello got printed after the entire for loop was executed. So in this block of code, these 3 lines are actually the for loop. This is a completely independent line. It's got nothing to do with the for loop, right? So was this some other language, you would basically be doing the same code in, say, for x in this, and then open a curly brace over here, and then go down, and then at this point in time put a new line, and then you would close the curly brace, and then you would, so this is your syntax, okay? This is how it would be in most languages that you might be familiar with. Python says you don't have to do this. Curly braces are not actually put there. You just simply put a colon. You don't need these round brackets, nothing of that sort, and simply this is how you get a for loop, right? So it's important to understand that how you indent makes all the difference. So there are various statements like for, if else. All of these will use this colon syntax, wherein you basically put a colon, and then anything that after all the new lines that follow after the colon, if they have an indentation, they're part of that colon block. And if they don't have the indentation, the block is stopped, right? So we need to really understand this and kind of keep this in our mind, that indentation is the key. Like other languages say you put your curly braces, you indent your code any way you like. I will only execute what's inside the curly brace, right? Python does not say that. In Python, the indentation means everything. So you have to actually properly indent your code in case of Python, right? Now let's run through a little further, right? Now, you can also put comments inside the for loop, right? So if you see here, we actually have certain comments which start with the hash. So this is a comment, and this comment is indented. This comment is also indented. So I can put comments within the indentation, and I can have my print hello. This breaks the for because this actually goes outside the indent, so it puts a reverse indentation. The moment I do that, my for loop is broken. So I can see this comment is placed inside the for loop. Here's another comment within the for loop, and this comment is outside of the for loop, right? So I can run through this. My output will look same as before because a comment is totally ignored from the execution, right? Now, I can also have a comment that follows a line of code. So I could actually write print hello, and in front of that, I can write a comment like this line prints hello, right? This is a valid comment. Comments don't always have to be independent lines, right? Comments could actually follow existing lines of code. However, once you put a hash, you cannot have a line of code that follows after the comment. That can't be done. So you cannot have code after a comment, but you can have a comment after the code, right? This is pretty similar to most other languages. So most of you should be familiar with this type of coding. Now, moving forward, so just prints hello, right? Moving forward, what happens in the event that we use a for loop like this, okay? And then I have print x, and then I have print x into 2. So I'm just multiplying the value of x by 2, and I'm printing it. And then I have this comment here, but this comment is not indented, right? This comment is simply not indented. So in this scenario, what is the expected outcome here? Will this comment break my for loop, or will it not break my for loop, right? This is an interesting question. Now, if I run this through, you will find out that you printed x has a value of 1, it printed 1, 1 into 2 is 2. Then it printed 2, and 2 into 2 is 4. Then it printed 3, and 3 into 2 is 6, right? So you can see that both the print statements, the first print statement print x, and then the second print statement print x into 2, these both print statements got included within the for loop, right? They're not actually outside the for loop. They're both included within the for loop. What does this mean? This actually means that this comment did not break the for loop, right? So at this point in time, I have two choices, right? I can actually write the comment the way I've written right now, or I can write the comment with the indentation. Now, it is really important to understand that it's a good practice to indent your comments along with the general indentation that you want to follow on the code, right? The reason you do so is because the code may not always be like this, right? You could have a lot of lines of code in between. So it could be like this, and then you have several other lines of code written here, right? And there could be hundreds and thousands of lines written here. And then after that, you have this rogue comment sitting here. And at this point in time, it's very, very easy to lose context that this print line is actually within this for loop. It's extremely easy to lose context that this print is within the for loop. However, if this code was arranged this way, I now know that this is where my for loop started and it's not ended. Up to this point, my for loop is not ended, right? So it makes it really easier for me to look at it. Obviously, this is just I typed it. These are not actual lines of code, right? But if these were actual lines of code, you can imagine how hard it would be if your comment was wrongly indented. So always follow a good practice of properly indenting your comments because it makes your code really, really readable, right? Now, moving on further, what's interesting to note is we actually did not even use semicolons in Python. So you might have noticed that most languages actually use a semicolon at the end of each line. So when you end a line of code, you put a semicolon there, right? So the question is, will Python allow semicolons? Like, can I write print hello with a semicolon and I might type a semicolon just because I'm used to typing semicolons? Like even me personally, I've coded a lot in Java, I've coded a lot in C, C++, and I'm simply used to typing those semicolons, right? So if I type a semicolon, is that going to be okay, or is Python going to give me a problem, right? Now, the answer to that is it's not going to give you a problem. So if I actually run this through, you can see it works, right? So I can have a semicolon or not have it, it works. However, it is common practice in Python to not include a semicolon. So you don't always include a semicolon. So most programmers in Python will avoid semicolons. In some scenarios, you might actually use semicolons. So semicolon is provided as an optional line ending. In many programming languages, it's a mandatory line ending, which means the logical line of code doesn't end until it encounters a semicolon. In Python, a line ending with a semicolon is completely optional, but there are situations in which you might actually find it useful, right? So let's look at this example, and this is a very simple example, right? And in this simple example, we're going to look at, I want to write basically two lines of code on the same line, right? So I can say print hello, semicolon, print world, right? And will this work, right? The answer is yes, it will work, right? So you can see it printed hello and it printed world, right? But can I do this differently, right? Can I actually remove the semicolon and do this? And if I run this, you can see, no, it won't, right? So congratulations, we've got our first error, and we can actually see how error shows up, right? And in this case, it says invalid syntax print, right? So this print world is not actually going to work. It says this print function. It doesn't really understand what syntax is going on, right? However, if I include the semicolon, it works perfectly fine, right? So there are situations in which where you want to just reduce the length of your code and you want to write a few logical lines in one single line of code. You can actually separate your logical lines with semicolons. So semicolon is provided as a feature. So in this scenario, you would write the semicolon. However, if you were to write this code this way, I strongly recommend you avoid the semicolon because that is the most commonly followed practice. You could put it like this. You could put it like this. It's just extra characters. Now, if you're really finicky about things, each and every character you type actually increases the size of your code because it's one extra character in your lines of code. So it's unnecessary increase in code size anyways. But most importantly, it's a common practice to not actually use the semicolon. So this is how I would recommend you do it. However, in this scenario, you can actually make use of that semicolon to logically inform the interpreter that we are indeed looking at a new line of code after the semicolon, although you typed it on the same physical line. Right? So these are a few of the differences that Python has amongst other languages, and predominantly being the no need to write a semicolon, the no need to define the data type of variable, and logical blocks of code actually follow indentation structures after a colon, right? And we will look more of these further down in the training. Now, let us look at some of the control structures in Python. So I'm still on lesson 2, and if you can scroll down further, you will see this if statements, the title if statements. So let us look at the first control structure, which is an if statement in Python. Right now, to look at an if, what I'm going to do is I'm going to simply import the package called random, and then I'm going to create a random integer between 0 and 10. Right, so this will produce an integer between 0 and 10. I assign it to a variable called a. Right, I'm actually defining the variable in the scope, and I'm calling it a. And if I want to write an if statement, then this is how the if statement would look like in Python. So I start with if, right? This denotes that I'm actually beginning the if statement. Then comes my condition. So this part that you see here is the condition of that if statement. The colon indicates the starting point of a logical block. So within this block, anything that is added within the indentation becomes part of the if statement. So this is fairly simple program, wherein this program will generate a random number between 0 and 10. This if statement will see if that generated random number is less than 5. And if it is less than 5, it'll print the specific output, which is the random number is less than 5. So this will get printed if the number is less than 5. So let's run this, right? And when I run this, you can see nothing got printed, which means the random number was greater than or equal to 5, right? The next time I run it, I see this output, right? And I can keep trying this multiple times over, right? And different times it is obviously going to give me different responses because that's what random does, right? So I can see that this line of code is actually executing within the if statement. So similar to other structures, you start with the colon until you do not remove the indent, which is this indent which is there until you do not remove the indent. Every line of code that you write under this becomes part of the if. So whatever I write here becomes part of the if. Anything I write here becomes part of the if. This is all part of the if statement until I break the indentation. Right? Now it's important to note in some languages you would have to use those round brackets, right? So the condition of the if would have to be inside a round bracket. Python does not require you to have round brackets. However, those are optional. So they don't actually mean anything. So if you're more comfortable with something like this, you can actually write it this way. It doesn't mean anything. It's the same. Effective result is kind of the same. It's not mandatory. Right? But it's not common practice to include the round brackets. So I would recommend not actually including them at all. Right? Sorry about that. Okay. So this is how you would basically do it without including the round brackets. Now, moving on further, let's look at how you would do an else statement along with an if, right? So this is fairly simple. So you basically simply type else along with your if, and this else becomes now part of the if statement when it's an if else statement, right? So if number is less than 5, I would print this saying that the number is less than 5, and else I would print the number is greater than or equal to 5, right? So because my if condition is less than 5, so even if the number is 5, it would come into the else statement, right? So I can now execute this and I should expect at least one line of output, right? And it is consistent. I'm actually seeing this minimum one line of output, right? So, and it will be a different line of output, every time. So it can keep generating is less than 5. Now it says, see, the random number is greater than or equal to 5, right? Because we know that the random is doing its job, and it's producing a random number whenever I want it to, right? So this is how you would simply write an if and an else statement, right? Now, how about writing an if, else if, and an else, right? Or else if, for that matter. So Python uses a very different nomenclature, primarily when it comes to the else if. So most of you would be comfortable writing else if as else if, which is the ELSE and if. But in Python, you don't do that. You actually write it as elif. So elif stands for else if. So it's a shorter notation of writing else if, but it does kind of the same thing as writing an else if, right? Now, this is a simple else if statement. So you start with an if, you start with an else if. You can have as many blocks as else if you like, right? You can put any number of blocks like any other programming language. You can have only one block of else, right? Any number of blocks of else if, one block of else. Now, anything you put inside the else if block until you break the indentation comes as part of the else if. And similar to anything you put inside the if block, until you end the indentation, it comes inside the if block, right? So you don't have to write the parentheses, the curly braces are not necessary here. You can optionally write them if you so desire. They're not necessary. It's not common practice. So this is the standard syntax that you would use in Python to write an if and an else if and an else statement, right? Now, let's look at kind of writing certain complex conditions, right? So let's say I want to do if a less than 10 and a modulo 2 double equals to 0. So a modulo 2 double equal to 0. So this expression is essentially going to check if the number is even or not, right? This is a common expression to check if the number is even. So if the number is even, it is divisible by 2. If it's not even, it's not divisible by 2, right? So that's a simple logic there, right? So I want to write an AND condition. So I write AND with AND, right? In many languages, you might be familiar with writing AND as double ampersand. So you might be familiar as writing it as this way. However, this is not the way you write AND in Python. So this is not an accepted syntax. So AND must be written as AND, right? So I can execute this code, right? And I can see that this is an even number less than 10, right? And we took a from the previously generated random number. We didn't explicitly generate it again, right? So this random number is less than 5, and this says this is an even number less than 10, right? So this number is clearly either 2 or 4, right? It's one of the two. So this is how you would write an AND condition. That is what I wanted to show here, right? And you can write as many AND conditions, OR conditions, all of that. And if you don't want to write complex conditions, then you can always write those. You can include those brackets. You can include certain conditions within brackets, and then you can write subconditions outside those brackets. So all of that can be done to write complex conditions within an if statement, right? Now, how would you write an OR, right? So let's move on further. OR is simply written as OR, O-R. So this is common practice. OR in many other languages, you might be familiar to having those, double pipes, and that would basically become your OR. Python doesn't do that. It basically says just put it as OR, O-R, type it in, and that's it. It becomes OR. So over here, you can see we are actually looking at if a less than 10 or a modulo 2 double equal to 0. So if this condition is satisfied, we know that this is a number that is even, or it is a number that is less than 10. So if the number is less than 10, it will qualify into this statement. Or if the number is even, for that matter, it'll qualify in that statement, right? And else, I can say this is an odd number that is greater than 10, right? So I could write it in random generation here. Now, moving a little further, let's look at if we can nest these statements within each other, right? So this is also completely supported. So you can have an if within an if to actually write greater complex logic. So in this case, let's try generating a random number that's random between 0 and 200, right? I'm just going to execute this line of code so that you get this output, right, which is fine. Now, moving on, let's say I put this condition where if a greater than 50, I can say print greater than 50, then I can have a subcondition, right? So this if, the second if, is inside the first if because it is indented. If it was put this way, it wouldn't be the same thing. So if it was put this way, the if would be outside of the other if. But because I have it indented, I have a nested if statement, so which is an if within an if statement. And here we actually have an else. So we actually have an if else within a primary if-else statement, right? So this becomes your primary if-else statement, and this becomes your nested if-else statement, right? So the moment a greater than 50 is qualified, it prints greater than 50. If a greater than 100, right, then it prints also greater than 100, which means the number is not only greater than 50, it is also greater than 100. Else it prints not greater than 100, right, which is correct. If it's not greater than 100 here, it will print not greater than 100. And else it will print less than or equal to 50, which means if this condition was not satisfied, it would come directly to this print statement and it would say that the number is less than or equal to 50, right? This is fairly straightforward. I can run this through. See, it says greater than 50, but not greater than 100. I can run it again. It says greater than 50, also greater than 100, right? So I got a different output this time. I can run it again. Greater than 50, also greater than 100. Again, greater than 50, not greater than 100. And again, right, greater than 50. So we are always getting greater than 50, right? It's not actually necessary. This is completely random, right? So there are occasions in which, like right now, you can see that we got a less than or equal to 50, right? So you can keep trying it. Don't get confused. It's very straight logic, and random sometimes tends to have a bias towards a particular bucket of values. So if you keep running it again and again, it will for sure be random, but for 4 or 5 runs, you can land up having similar results. So that's perfectly normal, right? Now, moving on, let's look at an interesting statement. So there is a statement called pass statement in Python, right? And we'll be using this pass statement in multiple places, right? So let's say I actually put a for loop in, and we're going to come to loops a little later down, but I'm just going to put it through. So let's say for letter in Google, wherein we're actually looking for for all letters inside the word Google. So it's going to iterate one letter at a time. And I say if letter double equals to G, which means if the value of the letter is equals to G, then I say pass, else I can say print letter L. So in the event that I wanted to print Google by skipping all the G's, I could do something like this. However, if I completely missed out the pass statement, if I wrote something like this, I would get an error, right? So before we do that, let's actually look at what is the output that we get for something like this, right? So I can actually use the 2 indents, right? And I'm going to run this through, and you can see that it gives me, instead of printing Google, it prints me O-O-L-E. So in the G-O-O-G-L-E, it missed all the G's and it printed the O, the first O, then the second O, then the L, and then the E. So it printed the O-O-L-E, Ole. That's what it became, right? So Google became Ole. However, if I was to remove this pass statement and try running the same thing, right, what would happen? You see, immediately it gets an error because it expected an indented block, right? So there was supposed to be a line of code over there, which was not there, right? So in such situations wherein the system syntactically expects a line of code to be there, but you don't explicitly want to put a line of code there, you can just simply type pass, and pass is essentially a no operation. So it's a placeholder line. It kind of fills in a line of code, but this line of code does nothing, right? So it's just a pass, which means does nothing. Now, in some languages, you might, when you define functions, you might return 0 or return -1 as default values, or in some languages like Java, you primarily follow the practice of returning null, or sometimes you follow the practice of throwing an exception saying throw this function is not yet supported, right? So in Python, the common practice is when you create functions, if you have still to implement them, or you want to just give a default, implementation at places, you could just write the word pass, right? And you might notice this in several Python programs when the developer has not yet written the logic. Like in this case, if I've not written the logic of what should happen inside the if statement, I intend to write it, I've not yet written it, I can just write pass and I can forget about it. But I can write a comment here like to do implement this later, right? I can actually keep that comment there and I can come back to it. But for now, so that syntactically doesn't give me any error, I can simply write a pass statement and move on, right? So I want you to try this through and run through the code and see if it's working for you. You can play around with it and see if there are any combinations that you can discover where you have challenges, and ask questions, if any, around the same. Up next, let's look at loops. So if you go into loops, Python has two primary loops, which is while loop or for loop, right? This is similar to other languages that you're familiar with, wherein you can have a while loop or a for loop. Now, we will start with the while loop. So here is a simple example of how a while loop looks like. So I create a variable called count, and I set count to a value of 0. And then I can say while count less than 10, I can do whatever I want inside this while the count is less than 10. Now, here I'm just simply printing the value of count, and I can say count is, and I can say count plus equals 1. This increments the value of count. So the first line prints the value of count. Now it increments the value of count. So if I'm running through this, you can see that it printed count from 0 to 9, right? And that's until it's less than 10. So this is how simple while loops are from any other programming language. Python has a similar syntax for this, right? You can notice that we used a different form of a print statement here, wherein you can add as many parameters as you want on the print, and it'll keep appending them to your output, right? So if I can actually even remove this space. So if I remove this space and I run this, you can see it still comes with the space. So if you separate it with a comma and you put in extra parameters wherein count is the second parameter to a print function, it'll actually append a string, but when it's appending the string, it adds that logical space in between. So and it's not intelligent enough. So if you explicitly put a space here, it's going to put an extra space out there. So you can see it's a little more far separated. If you want to really look at this, I can actually add extra spaces and see what happens. And you can see the number went far away, right? So this is not intelligent enough. So you have to keep in mind how many spaces you put there. And this would be the right way to do it, right? So the while loop will basically run as many times as the condition is satisfied. The problem with the while is it will never exit until you actually voluntarily dissatisfy the condition, which means you have to increment the counter in this case, and the counter at some point in time has to not satisfy the condition. Now, similar to an if statement, a while loop can have complex conditions. So it doesn't have to be one condition. You can actually write and another condition or another condition, use curly brackets, all of that. And similarly, until you break this indentation, any line of code that you write inside the while clause remains as part of while, right? Now let's move further down, right? I'm going to take one more example wherein you can actually have nested loops, right? So you can have a while within a while, and there's no restriction to do that. You can have any number of nestings that you like. Now, the first loop that we have here is almost the same when we start with count 1. We don't call it count. In the previous case, we called it count. In this case, we call it count 1, and I say count 1 equals 0. Then we say while count 1 less than 5, right? Count 2 equals 0. Now this is defining a new variable called count2, and the statement is inside the primary while statement. So this is a completely independent variable, but it's nested within the primary while variable. And it is nested because this is indented. If it was not indented, it wouldn't be nested, right? Now, the next line after that is a while, and I say while count 2 less than 2. So this while loop will run 2 times until count is less than 2. And then we print the value of count 1 and count 2. We print both the values of count 1 and count 2. And you can see how we have done it. We've actually just put a comma. So this whole part is the first parameter. This is the second parameter. This is the third parameter. And this is the fourth parameter, right? You can put as many as you like. It's kind of never ending. Just keep adding it. And this will keep concatenating the objects together and create a logical output for you. Now, this 2 lines of code, because of the extra indentation, right? This indentation which is there, these 2 lines of code come inside this secondary while loop, right? They're within the while loop, which means when this while condition is satisfied, these 2 lines will keep executing within that while. However, the line count 1 plus equals to 1 is not part of the inner while. This line is part of the outer while, right? So count 1 plus equals to 1 is part of the outer while, right? So this makes sure that outer while runs 5 times, and inner while, which is this, runs 2 times, but it runs 2 times per iteration of the outer while because it's a nested while loop, right? So if you're coming from other programming languages, this should be fairly straightforward for you. So let's run this through. you can see that it prints count 1 equals 0, count 1 equals to 0. Then it prints count 1 equals to 1, count 1 equals 1. Then it does count 1 equal to 2, and then and it prints 2 times 3 and 2 times 4. So all of these get printed twice. However, for each value, each single iteration of count 1, it prints different values for count 2. So it will put count 2 as 0 and 1, 0 and 1, 0 and 1. So you'll end up for a value of count 1 of 0, you'll land up with a 0 of count 2, 0 of count 1, you'll end up with a 1 of count 2, and so on and so forth, right? So this is fairly straightforward, wherein for each iteration of the outer while, it is doing 2 iterations of the inner while, right? So you can have nested whiles. Now, moving on a little further, let's look at something interesting that Python does, right? So Python doesn't just have a simple while loop. It actually has a while with an else. Right? Now, what does this mean? What is the meaning of a while with an else? Right? Now, this is where it gets interesting. So let's look at this example wherein we set number equals 0, and then while number less than 5, print number is still less than 5, number plus equals 1. And then you have an else statement which says print number is no longer less than 5. Right? So the else is printed finally after the while loop executes. So let's just run this through, and you can see that this statement got printed 5 times, because for 5 times the number was less than 5. As soon as number became equal to 5, it went to the else block and it printed the else block. Correct? Now, it's a little confusing at this point in time on why you would need to have an else block, because if the while was not satisfied, you would naturally print this line anyways, right? So here is an alternate code. So if you look at this code, right, this code does exactly the same thing as the above code. I didn't have to use an else statement here. I just had to put the print line with a reverse indentation, which means break it out of the while loop. And if it's out of the while loop, it's going to print itself the moment the while finishes executing. So why do I need an else block to do this? Just to confirm, we'll run this through, and you can see that indeed the output that you get here is exactly same as the output that you get there. Right? So both programs produce exactly the same result, right? And this is what is your natural understanding, that anything you put outside the while is anyways going to get printed after the while. So why do I need this else statement to print after a while loop, right? That doesn't make sense to start with. In the beginning, it's very confusing, because other languages that you're familiar with most likely don't have a syntax like this. They don't have an else statement that follows a while. So this can be confusing in the beginning, but it's an important construct of Python, right? Now, let's look at a few other examples here, right? Now, if we take number equals to 5, we're going to run this code again. Number is still less than 5, number plus equals to 1, else number is no longer 5, right? This is what we saw at that point, and it basically prints the else. So what we did here is we actually started with number equals to 5, which means we are seeing if this else will print if the while was never entered. Like, we're looking at, is it that this else will only print if you did go inside the while loop at least once? And the answer is no, because in this case, the while loop condition, the primary condition of the while loop, which is number less than 5, was never satisfied. We started with number equals to 5, so this condition is never satisfied. So when you run this, you can see it never printed this line of code, right? It never went inside the while loop to print that line of code. It directly came to the else and it printed the else statement. But it did print the else statement. So what is the difference, right? If I didn't have the else at all and I had this program written just like this, it would kind of do the same thing, wouldn't it? Yeah, it does. See? It outputs exactly the same thing. So I'm still confused here on why exactly do you need else, right? And I'm pretty sure you might be confused too on what difference is this actually making, right? So let's take the below example in this case, right? So we are going to start with a number equals 0, and we're going to say while number less than 5, we're going to do print number. We're going to number plus equals to 1, and then we have an if statement inside which says if number double equal to 4, then you break, right? And this is the first point in time where you're actually going to use break inside the while loop. So you can use a break, you can use a continue, or you can use a pass, right? So all three statements are valid syntaxes and they can be used inside the while loop. In this case, we're using the break statement inside the while loop, and we're going to see what the break actually does here, right? Now, if I run this program, it'll be interesting to note, right, that it printed number is 0, number is 1, number is 2, number is 3. It printed this. It didn't print number is 4 because the moment number touched 4, it hit the break breaks the while loop. Now, after it breaks the while loop, the expectation would be it would print this line of code, which is number is no longer less than 5. However, the number is actually less than 5. And this condition of the while loop was never dissatisfied. We did a break through the while loop. So the moment you break from the while loop, it breaks from the entire control structure. It does not break from just the first part of while, and it doesn't jump to else. It actually skips everything after, including the else, including any number of lines that you have in else. They're all skipped the moment you hit a break inside the while loop, right? And then it jumps straight out to this line which says print if we have completed the while, right? So you got we have completed the while right after this print number is 3, right? There was nothing in between that came up. Now, this is an interesting thing that one needs to understand in Python, right? Because if you were to do a program of a similar nature wherein you have the opportunity to break through extra lines of code that you might have had to execute after the while. So you had an intention to execute these lines of code after a while, but you simply did a break through them because there was some other condition that is not satisfied. Maybe you're trying to do a file read operation or something of that sort and it didn't go well. So you simply had to skip through a block of code. You can actually use a control structure like this, which allows you to directly break. And when you break, it can break everything that's written in the else, right? Now, if you had to do the same thing in other languages without the while and the else clause, your program would look something like this. So you would start with number equals 0, then you would create a variable called did break equals false, right? Now, it's important to note here that false in Python is written with a capital F, not with a small f. So if you write false like this with a small f, it won't work. Same is the case with true. You have to write it with a capital T, right? So it's capital F and capital T for false and true. Now, back to the while, we say while number less than 5, we do print, this all remains the same. If number double equal to 4, then I save it to a variable which is called did break equals 2, and then I actually break it. And then I have an extra if statement here which says if not did break. It is important to note we have to write not in Python as not not. You do not write Python not in Python as this. This is not what you do. You actually put it as not, right? This is the right syntax for doing not in Python. And then you have this extra if statement. So what the previous program really did for us, right, is this program with the while and the else actually avoided us from creating this extra variable. We didn't have to create this variable. We didn't have to set the variable here. We did not have to create an extra if statement to check for the state of that variable, right? So this is giving us finer control over what execution we want to do based on the outcome of the while itself. So at this point in time inside the while loop, I can actually take a call if I want to have a piece of code run after the while or I don't want it to run after the while. So I can choose to skip it, right? So this is a much advanced control structure wherein while in Python with its else clause really offers us far greater degree of control over basic control structures than what most other languages do. And it's very, very common to see a while with an else clause. So if you see a while with an else clause, I hope that now you won't get confused because you will know what it is. The first time I saw it, I was really confused. I started searching for the if statement. The moment I saw an else like this, I was looking at, wait a second, where is the if, right? Where did the if go? Is this else belonging to this if? No, this else is not belonging to this if, right? This else is actually belonging to the while. So I got confused for the first time, and it took me a while to understand that while loops in Python actually support else statements as well, right? And this is a common practice. It's common practice to use that else block to conduct logical operations with a while loop. Up next, let's take a look at for loops. For loops in Python follow similar syntax to most other languages, but we do not have the ability to define the iterator, which is the typical int I equals to 0, I less than length, I plus plus. We don't do that in Python. We actually take any iterable object and then we assign it to a variable and then we iterate it inside the for loop. So let's take a look at this example to start with. right? So over here, we have defined an array, or you can call it a sequence or a list, as you may call it, of fruits. And this has apple, orange, and mango. So 3 fruits inside the list. Now, when we write the for loop, you can see that we say for fruit in fruits, right? So this fruit is a new variable that we have created, and fruits is actually the sequence that we have. This is an iterable sequence. So because you can iterate through the sequence, the for loop is able to do the iteration. So when I run this through, you can see that it prints all the fruits on each line. Now, for loops follow the similar colon syntax, just like while loops. So anything that you write inside the colon until you break the indentation becomes part of the for loop. Now, the same example, if you were to do in a language like Java, you would probably write the code as you see here, right? So you would basically say for int I equals 0, I less than fruit.length, I plus plus, do whatever. So the closest equivalent to this code in Python is how we have written it here, wherein you say for index in range, and range produces a range of numbers starting from 0 up to the length of fruits. So we used a secondary function called len, and len gives us the length of fruits, which is the length of the sequence. And the range produces serial numbers starting from 0 up to the value provided, excluding the value, of course. So if you were to write int I equals 0, I less than fruits.length I plus plus, this for loop syntax here would do exactly the same thing. And for each iteration, it would give you the value of index, because you're actually iterating here on index and not on fruit, right? So you're saying index in the range, length of fruits would be 3. So you just basically say index in the range 3. And then in each time you print, and when you're printing, you do fruits of index, because when you pass the index here, you can actually pick up the value. So index 0 is apple, index 1 is orange, index 2 is mango. Right, so those items would respectively print here. Now, just like we can actually just run this through and see how it works. So it gives you the same output. It's the same way of doing things. However, I would like to mention here that this syntax that you see is not a common practice in Python. So if you did have an iterable object, you would basically use this syntax. So for fruit and fruits is actually the one that you should be using, not the one in range. Now, similar to while loops, for loops also support the for with else. The purpose is exactly the same, right? So this is the formula, this is the basic structure, or as I would say, for with else. We can run this through and we can see that when the for loop finishes iteration, the else takes over and it says finished printing fruits. This gets printed in the else. Now, this is exactly same as the while, wherein if you do write a break inside the for loop, which means if you break the for loop, the else will also break. So the else will not print if you break inside the for loop. So this is giving you a finer control on the fact that if the for loop executes completely, then execute the else clause, but you do have the option in between to completely skip the execution of the else clause by breaking the for loop. So this is very, very similar to how the while loop works. And for with else is a very common practice, so you might actually see a lot of programs in Python using the for with the else. Okay, so that's all we have for today. I hope you have had a great introduction to Python and can appreciate the capabilities of this language. I strongly encourage you to keep practicing the code, follow the instructions in the Cloudbook, and try all the programs yourself. Become proficient in Python, and you will be on your journey to becoming a data scientist. Do not forget, join us for the next session to learn about tuples, sequences, arrays, lists, functions, classes, and several other constructs in Python. We will also get an introduction to functional programming and how Python uses functions as objects, where everything in this Python is an object. So do not forget to go down to our channel, look at the BlobCity channel, subscribe to the channel so that you get notified of the next session. And join us for the next session to learn further about Python and move towards your goal to becoming a data scientist. If you're interested in trying any of our paid plans, then for our dear YouTube members, we have an offer for you. You can choose any of the plans of BlobCity, enter the coupon free14 during checkout, and you can use any plan of your choice completely free for 14 days. This option is available only to new users. So if you're a new user and you're taking a plan for the first time, you can use the coupon code free14 to get a 14 days trial on any of our premium plans.